This is a review of the standard board foot deduction rules. There's 5 of them that I'll present here as a review. Please let me know if you find this useful or if there's anything on here that's confusing. Thank you. So we'll start with the standard rule for volume deduction. This is usually applied to internal or heart rot decay or internal defects. It could be ripped out tissue. It could be things other than decay, but most commonly it's decay columns in the heartwood. So if we take this log that's 20 inches in diameter and 16 foot 6 inches actual length, and we scale that, see what happens. So what we have here is a 20-inch log in the upper example. The 20-inch log, it has a 16 foot 6 inch actual length. The defect is 6 inches at the top end, but it's 12 by 15 on the butt end. Okay, and you can see the graphic of this. So the cylinder goes through the entire log. Here's a real live log on the top, and you can see right through that log to the other end. Okay. So if we get a gross scale on this log, 20 inches, 16 foot, we know it's 290 board feet, gross scale. And we get that right from the table, from the log rule. That, again, I'm using international all the time. So either the one in your text or the one in the appendix to the wood measurement rules. But 290 board foot, international board feet for a 20-inch, 16-footer. So that gives us our gross volume. So the gross volume, now what about the defect? Well, the defect, if you recall, was 15 inches by 12 inches on the big end. Now, we can't use the bottom end, the top end, because there's more decay than that. I need to be able to cut out straight, long 16-foot boards, and I cannot do that. So you always have to use the dimensions of the decay on the big end of the log, if it goes through all the way. And in this case, it does, and the big end is 15 and 12. So we add a 1/2 inch in diameter around both sides of that. So that becomes 15 plus 1, a 1/2 inch on either side, and times 12 plus 1, times 16 feet in length for the decay, and then we divide by 16. Now this 16, as you recall from lecture, is a constant when we're using the international 1/4 inch. And instead of dividing by 12, we divide by 16 because there was already material taken out for kerf and shrink, and this adjusts for that. If you're using Scribner, you divide by 15. We will use 16 from here on out. 16 does not have to do with the length. It has to do with an adjustment for board feet that we've already deducted. So our defect volume then is, if you look 15 plus 1, 12 plus 1, it's 16 times 13 times 16 divided by 16, and you should have come out with 208. So make sure you do that. Make sure you understand that. So 208 is my defect volume. So to get my gross, I subtract the defect from the gross volume, and obviously I'm left with very little, 82 board feet. So that is the standard rule, and you will see that on the test. So be comfortable with that. Let me know if you have any questions. So again, you're going to adjust that column length. In this case, the column of decay went the entire length of the log. If it only went 3/4 the length, then I would adjust the length for that defect column. And yes, if you know the decay, and this comes with a lifelong practice, then you might be able to estimate how long that is and what the diameter might be in the middle of the log. So again, in this case, it's only 8 foot of decay. This is very common with butt logs. There's a particular brown rot on conifers that only goes up 8 feet into the log. It goes no higher. And so in this case, you can see a 10-inch diameter. So it'd be 10 plus 1, 10 plus 1 times 8 divided by 16 for this graphic at the bottom. Okay, because the column only goes 8 feet. So you're going to estimate that, and that comes with experience. The second of the standard rules is for diameter deduction. this one can be tricky because people forget the volume that we're looking at is the donut, right? So imagine if you look at the illustration down below, I have on the bottom top end of the log, the small end, the top, a 24-inch diameter inside the bark. And this is scaled at a 16-footer. But I have about 2 inches of sap rot on either on the bottom side that goes about a third of the way around the log, right? So 2 inches on the bottom. If I did this as a cylinder around the solid core of wood, then you would see that it'd be 2 inches on one end, 2 inches on the other, right? Of that 20, 4 inches, only 20 inches is solid wood. So what I'm going to need to do is calculate the volume of that donut with the 20 missing, right? So the 20 inches of solid wood is a core that we're not even going to worry about. So we got to do this in a couple of steps. What I need to do to calculate the volume, I can do the gross volume first, but then what I really need is that donut volume, not the interior volume at the end. I need to figure out what the volume is of just the defect. So let's go through that. So my gross scale, 24-inch, 16-footer, you go to the table, make sure you know how to do that, and as you see, you extract 425 board feet. But that's my gross volume. The trickier part here is getting the defect, because remember, the defect is only 2 inches, and it's only 1/3 of the way around the log. But the net core, I do have solid wood, 20 inches, 16 feet. So again, I go to the table and I get the net core, the donut hole, and the table tells me that that is 290 board feet, okay? I just see a mistake up here that I'm going to have to fix, but that should say 24-inch, 16-foot log, 425. 20-inch, 16-foot, 290. Okay, so what I know is that the gross volume, the whole log is 425. The core, that's solid wood, is 290 board feet. If I subtract those two, the donut volume is 135. That's that exterior donut of 135. Now, only a third of that is really defect, right? So that's what I got to calculate next. So the defect volume then will be a third. That donut volume divided by 3 is 45 board feet. That is all of that whole log. That is all that is defective. So what's my net volume? Well, the net volume is going to be my gross minus the defect. So my gross 425 minus the defect of 45 board feet, and I'm left with a lot of board feet here, 380 board foot net. Again, international 1/4 inch rule. Okay, the third of the standard rules is the pie cut. To me, this is easier than the last one. Let's say we have a gross scale of 12 inches, 16 feet. We have a lightning scar that you can see on this beech stem, and the lightning scar spirals around the log a little bit. We may have some other issues with it too, but let's just concentrate on the pie cut part of this. And so that lightning scar goes up the tree about half the length, but spirals around to eat up about 1/4 of the log. I don't know if you can see that at the top where it starts to spiral around. So that defect wraps around and eats up about 1/4 of the tree in whole. So let's start with the gross volume of 12 inches, 16 feet. Go to your table and you should get 12 inches, 16 feet, 95 board foot gross. But now I got to look at the defect. Again, I have it going up the log, spiraling around 1/4 of the way. So half the log, but only 1/4 of the diameter. Half the length, 1/4 of the diameter. So, okay, in case I cut that off. So my defect is going to be 1/4 of the 95 board feet. Okay, so I could do 95 divided by 4 or 95 times 0.25. So there's a defect of 2375 for 1/4 of the diameter. But now don't forget, I have length also. So although it's a quarter of the diameter, it's only half of the length. So now I take that defect and I divide by 2, or I multiply times 0.5, and I'm left with my final defect volume of 12 board feet. Best to round up, so 12 board feet. So this log has a 95 board feet gross, a defect of 12 board feet. How do I get the net? So gross minus defect leaves me with 83 board feet net volume. Okay. And with the board feet, it's okay to round to the nearest, but when it's a defect, I usually round up. If it would have been 11.3 or 4, I probably still would have gone to 12. Okay, so 83 board feet. So this one's pretty easy, but you got to keep in mind if it's the whole length, then it's divided by 1. If it's the whole diameter, then you have a problem. Okay, the next one is the length deduction, and this one's pretty straightforward, pretty easy. Usually this is handled in the woods by the sawyer. So here's my 12-inch log, 12 inches diameter inside bark on the top, 20-foot, 6-inch length. There's a crook of 4 feet on the butt, from the butt. I didn't say that really well. It's actually, in this example, it's the other end. But at any rate, first of all, let's get the gross volume, the gross scale. So we do that. 12 inches, 20 feet is 125 board feet. But what about the defect? Well, again, like I said, usually this will be bucked off in the woods. If it's not, then you're just going to scale it as a 16-footer. So actually, you're just going to scale it as a 16-footer. So what's your net scale? 12 inches, 16 feet would be 95 board feet. Now, if you find that the diameter changes and increases dramatically, then I don't think it's wrong to increase that diameter in your scale. Okay, if you want to do an estimate of what you think that diameter is, I don't think that's wrong. You're not cheating the mill. They're going to get the wood out of it. Okay, so I could have increased this diameter if I wanted to. I didn't, but I could have if I saw a significant increase. It should have been handled and bucked in the field a little more appropriately. Sometimes, however, if the log is long enough, and if the sweep or the crook occurs at the right spot, you can eliminate the defect by bucking the log properly and being left with 2 logs and not having call. Okay, so that's important. Okay, the last one I want to do is sweep. So this is the 5th of our standard deductions. Again, a 12-inch diameter inside bark top. The length is 20 foot 6 inches. And if you look at the second log from the right, you'll see the log has some sweep. So that's our defect. So let's get the gross volume first. 12 inches, 20 foot. So 12 inches, 20 foot. And the problem here is my defect is about 7 inches of deflection from the center of the log. Now, I am allowed a 1/2 inch every 4 feet. Okay, I'm allowed that. So what I'm going to do is I have 7 inches of deflection. Now, how do you figure this out? What you do is you run a tape from the center end to the center of the end, and then you measure the deflection with your stick from the center middle of the log. Okay, so I measure that deflection away from the center. How much does the center of the log deflect away from the parallel line? And in this case, it's 7 inches, but I'm allowed a 1/2 inch for every 4 feet. This is a 20-foot log. It's a 20-foot log. I'm allowed a 1/2 inch for every 4 feet. That means 5 of them, right? 20-foot, 24-foot segments. So it's going to be 7 minus 2.5 inches that I'm allowed. So I have a 4.5 inch diameter deduction, and I'm going to take away from that 12 inch. I kind of said we need to get the gross, but in this case, the deduction will be a diameter deduction So you don't even need to bother with the gross scale. So my net volume then would be 7.5 inches, 20 feet, right? So 12-inch scaled end, subtract 4.5 inches, and I end up with 40 board foot net. Okay? 7.5 should scale as a 7-inch 20-footer. 40 board foot. So that's how we handle those. Any questions, make sure you let me know. Thank you.